everybody, welcome back to chemistry. And so what I want to talk about now is how you can look at chemical reactions and subdivide them into four major types or categories. And so I have those four types or categories on this slide. So if I can increase the slide. Here, the first chemical reaction we're going to look at in just a second is called a combination reaction. And here I have sort of a generic description of how the reactants get together to form a product. I'll talk more about this in a minute. And then here we have an example reaction of this chemical reaction. And also, next, we'll talk about decomposition reaction, and you can see what follows is the generic description, and then we have an example reaction here. Another type is called a single replacement reaction. Here is the generic description of that, and here is an example of that. And then finally, we have a double replacement reaction. Here is the generic description of that, and here is an example of that. But first, let's go into the combination reaction. So one of the things you're going to have to do on a test is recognize when you see that a chemical reaction is a combination reaction. So let me show you how you go about doing this. And what I like to do is sort of focus in on this lower picture here. That kind of helps me understand what a combination is about. So a combination reaction is where you mix reactants together and you get a product. So here are the reactants that you mix together, and then maybe in some fashion you get the reaction going, and then once the reactants have reacted, you get this final product here. Now, let's step back and talk about what the reactants can be. So here we have molecule A. So molecule A can either be an element, as it looks like it is in this picture, or a compound. Molecule B here can either be an element or a compound. And so what you'll do is you'll mix them together, and then they can react, and what will happen is you see each of these A atoms here, they will bind to the B atoms. So here we're seeing 4 A atoms stick on to 4 B atoms, and so what you get in the end is here when the reaction is complete, you get a product here, and you can see that the product is made of A atoms stuck to B atoms. And so one of the things you might remember is when you have one element that is stuck to a different element, this is called a compound. And so you can recognize when you have a combination reaction, when you have two or more reactants, which are either elements or compounds, but in the end, the product here is one compound, and that's it, only one compound. So a great example of that is, say, taking the element calcium here and reacting it, mixing it with bromine, and then you get the compound calcium bromide. So the next reaction is a decomposition reaction, and I have a picture of that here. And so you can recognize a decomposition reaction when you start out with a reactant that is a single compound, and then you get the reaction going, and you produce from that products. Those products will be, say, either an element and another element, or it could be a compound and another compound. But other possibilities exist. You can produce 3 elements, you can produce 3 compounds, or 2 elements and 1 compound, and so on and so on. But the key to figuring out whether you have a decomposition reaction is what you start with. You must start with only one compound, and again, it breaks up into individual elements or compounds. And so I think you can sort of see that in this picture here. Here, for example, as one of the molecules as a reactant, I think you can see what will happen is it will some fashion when this reaction gets going, is that this compound will separate into its individual elements. And so that happens for all 4 molecules there. And so here is an example of a decomposition reaction. Note that you're starting with a compound, and then this is going to react and decompose to produce a compound and an element. Okay, so we'll move on to the next one. So the next one is a single replacement reaction. And so I have here a picture of what's going on. In a single replacement reaction, what you have to look out for is that you will have two reactants here and you'll have two products. So let's talk about what the reactants can be. So the reactants, one of them almost always is an element. And then here, the other reactant must be a compound. The compound can either be ionic or molecular. And then the products, you'll get another element and a different compound. So how does that happen? So let me explain. So what happens is this. You mix here molecules of A together with molecules of a compound called BC. And so what happens is this. You see this molecule A here? What will happen is it'll go up to molecule BC, and what A will do is it will knock off B from C and stick to C so that we get this molecule here. And then B flies off. And so basically the reason why it's called a replacement reaction is because you're taking A and replacing B to get it to bind to C. So you get molecule AC and you get B flying off. So here is another example here. A can attack this molecule BC. A again will stick to C, and then B will just go flying off into space. And so this is an example of a single replacement reaction. And so here we have an example of that. And so maybe one of the ways you can recognize that this is a single replacement reaction is we have in the reactant side of the equation a element and a compound, and we're getting on the product side a different compound and a different element. Okay, so we move on. And our final reaction is the double replacement reaction. And so here I'm looking at an example of this. And so what I want you to notice in a double replacement reaction, we have two reactants here and two products. And the reactants, they must be two. You can't have three, you can't have one, you can't have four. Same thing with the products, you must have two. Also, going back to the reactants must be compounds. Most of the time, they'll be ionic compounds. Sometimes they'll be molecular or covalent compounds, but they must always be compounds. If you see an element as a reactant, it is not a double replacement reaction. Finally, the products also have to be compounds. If you see an element as a product, it is not a double replacement reaction. Okay, so let me explain how this works. And so let's focus here on this reactant, AB, on molecule AB here. So here is molecule AB. I want you to look what happens. So AB, we can think of it this way. We mix it with molecule CD, so think of it traveling over here. Now, what will happen is that the blue atom, which is A, will knock off the red atom, which is C, from the white atom, which is D, and then stick to D. It'll stick to the white atom. So the blue atom replaces the red atom and sticks to the white atom. And so you get this molecule here, which is AD. But at the same time, what will happen is that the red atom here, which was knocked off, what the red atom will do, which is C, it'll travel back to, I guess, now it will find B and then stick to that. So this is a double replacement reaction, is because you have two replacements going on in the reaction. One replacement is here, the blue atom replaces the red atom and sticks to the white atom, and then the red atom travels over here and it replaces the blue atom and sticks to the green atom. So now what I'm going to do is I'm going to go over these equations on the board. We're going to try to identify the type of reaction they are. So if I can decrease the slide. All right, so here we go. So here, let's look at our first equation. So here we have, as reactants here, two compounds, and then we have products here that are two compounds. And so I think from that information, I can figure out what the answer is. But let me tell you what it isn't and why. So one thing it's not, it is not a combination reaction, because in a combination reaction, you would have only one product. We know it's not a decomposition reaction because in a decomposition reaction, you would only have one reactant. We know it's not a single replacement reaction because in a single replacement reaction, you have an element in a compound producing an element in a compound. So here, I think you can see that this is not an element here. Potassium fluoride is a compound. Sodium chloride is a compound. Two compounds as reactants, two compounds as products. Whenever you have that happening, this is a double replacement reaction. So I'm just going to write DR for double replacement. And so actually you can sort of see the mechanism here. It's kind of fun. What you can see is here the potassium ion will pop off here and travel over to sodium chloride. And the potassium will replace the sodium and bind the chloride. And then the sodium ion flies off and goes back here and binds to the fluoride ion. And so that's how you get the two products. Okay, let's move on to the next one. So the first thing I want to do is point out here that we have a chemical equation and it looks like it's balanced. The way I know that is that here we have these coefficients in front of the formulas. And so when you're figuring out the type of reaction, you can pretty much ignore here the coefficients. What we're really needing to do to figure out the type of the reaction is to analyze the kinds of reactants and products that are found in this equation. And so one big hint is that here as a reactant we have one compound. We don't have two compounds, one compound. And here as products we have a compound and an element. So what kind of reaction would this be? Well, if you're starting out with one compound, you're breaking it down into pieces, say here a compound and element, what this is going to be is a decomposition. So I'm just going to write decomp for that. Okay, with this next equation, it is a word equation. So let's see if we can figure out what this is. You can see on the reactant side, we have two elements. On the product side, we have one compound. This is just a phrase, iron oxide, which is a compound. So it looks like these two elements are combining together to form this compound. You know you have a combination reaction when you have pieces forming together to form one compound. So this is a combination reaction. Okay, the next reaction is a little bit more difficult. Again, it's a word equation. Maybe a little bit more difficult to see what this is all about here. But here, potassium hypochlorite, that sounds like a compound, and maybe you recognize this compound has a potassium ion, and then hypochlorite is an ion also. It's a polyatomic ion, it's ClO minus, and then it's reacting with another compound, magnesium sulfate. Magnesium is Mg2+, sulfate is SO42 minus, but then the products here are written here. We have this arrow here, the products are written here, and we get two new compounds. We get magnesium hypochlorite, so that's different than potassium hypochlorite, so this is a new compound, and we have potassium sulfate. So when you see a chemical reaction that has two compounds as reactants and two compounds as products, then you have a double replacement reaction. So I'm going to write DR for double replacement. And in fact, you can sort of imagine the mechanism here in that the potassium ion breaks off and replaces magnesium, binds the sulfate, so you get here potassium sulfate. And then magnesium breaks off, replaces potassium, magnesium binds the hypochlorite, so you get magnesium hypochlorite. Okay, the final reaction, so again, I see chemical formulas with coefficients in front, so this is a balanced equation. When you're doing this analysis, just ignore the coefficients. So I'm going to put X here in front of the coefficient. So let's see if we can figure out what the types of reactants we have and the types of products we have in this reaction. And so here we have aluminum metal, which is an element, this is found in the periodic table, reacting with hydrochloric acid. You can call it hydrogen chloride. This is a compound. Happens to be a molecular compound. That's fine, but it's still a compound. So we have an element and a compound reacting to produce a new compound, which is aluminum chloride, and a new element, which is hydrogen. So this is going to be a single replacement reaction. So I'm going to write SR for that. And so if you're curious as to how this works, you can think of it this way, and that the aluminum here, what it'll do is it'll travel over to the HCl. The aluminum will replace hydrogen and bind to chloride. Might pick up some extra chloride ions on the same during this process, and then releases hydrogen off as a gas. So thank you for listening to that, and we will see you next time.